Okay, we're moving on to our next section. This is going to be a long section for us, and we're going to do a quiz on 2.1 and 2.2 after this section ends. Important thing to note about this section is I need to see your work for these problems. So you're going to need to make sure that you're submitting the assignments in the way I ask you to, with you doing it on a piece of paper and sending me a picture. You can figure out how to send pictures if you don't have a phone, or if your phone is not good enough to take a picture very well, you can do it from your Chromebook. I have videos on your classroom page on how to do that. So just check those out. That's under the extra help materials. Okay, so this is 2.2, solving equations, quadratic equations algebraically. Now we're solving them using algebra as opposed to graphing. So quadratic, or a second degree equation, is just one that can be written in the form ax squared plus bx plus c equals 0. And that's where a, b, and c are real numbers and a is not equal to 0. So this would either just be like 1x squared, or just x squared plus 3x plus 6, or even 2x squared plus 4x plus 6, where each of these are just numbers, are a, b, and c, and a can't be 0. Either of the other two could be 0. This could be 0x, which would just make this x disappear, or this could be a 0 on the end, which would make that disappear. The reason that this is such a long section is because there are 4 techniques used to algebraically find exact solutions of quadratic equations. So techniques that can be used to solve some quadratic equations include factoring, taking the square root of both sides of an equation, and that's really what we're going to get into today. Additionally, we can do completing the square and using the quadratic formula. The difference between these two and why I broke them up is that these techniques can be used for solving equations, but they can't be used to solve all equations. We can't factor every quadratic equation out, and we can't just take the square root of both sides for every quadratic equation. The techniques that can be used to solve all quadratic equations are completing the square and using the quadratic formula. We can solve every single question using those two. The only problem is, those are the harder. It's the harder methods to do. Take a little more time, a little more work. Okay, so let's get into solving by factoring. So there's a standard procedure for solving by factoring. The standard procedure is to get everything on one side of the equation. So if I look at this question, I have 3x squared minus x equals 10. To factor that, I'm going to need to set the equation equal to 0, which means I need to get this 10 back over to the other side. So I'm subtracting 10 from each side. That gives me 3x squared minus x minus 10 equals 0. Now that I have it set equal to 0, I need to factor it. So when I factor the left side out, that means that I need to come up with 2 sets of parentheses. And there's a couple things I can even do before that. The first thing I'm going to look for is a greatest factor, common factor of all 3 terms. Is there something that goes into all 3 of these? In this case, there is not. So there's nothing that I could pull out ahead of time. Okay. The next thing I'm going to look for is to see if these are perfect squares. Is 3x squared a perfect square? The x squared is a perfect square, but nothing squared gives me 3. Nothing squared gives me 10. So now I need to figure out what would multiply to give me 3x squared. Well, that's simple. It has to be a 3x and an x. Now I need to figure out what multiplies to give me negative 10 and adds to negative x. So I can look at some of my factors of 10. That would include 10 and 1 and 2 and 5. Now my factors of 3 were only 3 and 1. So I need to figure out what's going to add together to give me a negative x. If I did 3 times 1, that gives me 3. And then 10 times 1 gives me 10. 3 minus 10 gives me negative 7. 10 minus 3 gives me positive 7. So that's not going to work. Additionally, I need to figure out what my signs inside of here are going to be. In this case, it's going to be a minus and a plus. And the reason for that is that as long as my back number is a minus, it tells me that I'm going to have a minus and a plus. If my back number was a positive and this was a minus, it tells me it's a positive or a minus and a minus. If my back number is positive and this is positive, it's going to be a plus and a plus. So in this case, I'm going to have a plus and a minus. Let's try to do the 3 and 1 and 2 and 5. If I do 3 times 1, or 3 and 1 and 2 and 5. Now if I do 3 times 5, that gives me positive 15. Minus 2 is going to give me 13. So that combination does not work. What if I do 3 and 2? 3 times 2 is 6. 1 times 5 is 5. 6 minus 5 gives me positive 1. But that kind of doesn't work either because I need this to be a negative 1. If I get the same number with different signs, that tells me that I just need to flip my signs. So I had been doing a minus 5 and a plus 2. That gave me a positive 1 in the middle. So I flip that and make it minus 2 and plus 5. Now I can check this right now and see if I did it correctly. I just have to FOIL it. 3x times x is 3x squared. Outer, that would give me 15x. So I did not put my 2 and my 5 in the right spot. So I have 15x minus 2x. That's going to give us a problem. So I need to reverse the order of these. It's going to be a minus 2 and a plus 5. Now whenever I multiply this out, 3x times negative 2 gives me negative 6x. 5 times 1, 1x anyways, gives me plus 5x, and then it's minus 10. Negative 6x plus 5x, those combine to give me negative x. So it's 3x squared minus x minus 10. Did all that just to show that's how I can check to see if I put the things in the right spot. Now I set both of these factors equal to 0. So it was 3x plus 5 and x minus 2. Set those both equal to 0. You get 3x plus 5 equals 0 and x minus 2 equals 0. Subtract the 5 over. 3x equals negative 5. Divide by 3, x equals negative 5/3. Add the 2 over. X equals 2. These are my two answers for this question. Don't worry, we will be spending some more time on factoring. How can I factor this one out? So I need to figure out what multiplies to give me 15. I know that this is a plus and this is a minus. So that makes, when I break this apart, a minus and a minus. I need to check to see if there's anything I can factor out of all three. There is not. So now I can just factor as normal. X and x multiplies to give me x squared. Now what multiplies to give me 15? As I said, I'm going to have a minus and a minus because this is a plus and a minus. So if the last is a plus and the middle is a minus, that tells you it's going to be a minus minus in here. Now, 5 times 3 gives me 15, and 5 plus 3 gives me 8. Since that's a minus and a minus, that would give me the negative 8. And now I can just break those two apart. X equals 5. Well, should show the actual step. X minus 5 equals 0. And x minus 3 equals 0. Add the 5 over, get x equals 5. Add the 3 over, x equals 3. And I'm done. I could check this by plugging it back into the question. 5 squared minus 8 times 5. That's 40 plus 15. That better give me 0. 5 squared is 25. 25 minus 40 is negative 15. Negative 15 plus 15 is 0. If I put the 3 back in, 3 squared, that's 9, minus 8 times 3, that's 24, plus 15. 9 minus 24 is negative 15, plus 15 is 0. We have another type here where we have x squared equals k. So when k is less than 0 or a negative number, so we're just saying for any real number k. So k can be any real number. Then if the number is less than 0, it has 0 solutions. If this number is equal to 0, it has 1 solution. And if it's greater than 0, it has 2 solutions. And those solutions would be the square root of k and the negative square root of k. So if I look at this first one, x squared equals negative 4, my answer for that one would be no solution. First reason being that k is less than 0, negative 4 is less than 0. So that tells me that there's no solution. But additionally, what number squared could give me a negative? Well, there's no real number that we can put in that would give us a negative 4. Anything squared is going to make it positive, so that automatically eliminates this as a real question. What about x squared equals 9? Well, 9 is greater than 0, which tells us it's going to have 2 roots. I can solve this by taking the square root of both sides. It gives me x equals, what's the square root of 9? 3. Then I also have to find the negative square root of 9, which is negative 3. Now, a lot of people struggle to figure out why that's true. The reason that that's true is because if I have 3 and negative 3, if I plug either of those back into this equation, 3 squared is 9, and we all knew that. But negative 3 squared is also equal to 9. Because any negative times a negative gives us a positive. So if I square either one of those, it would give me 9. That's why it has to be these two solutions, 3 and negative 3. Lastly, I have x squared equals 0. And if I look at the little table from above, it told me that if it's equal to 0, well then it is 0, and there's only one solution. That doesn't mean that's the only way we're going to see those problems. In this case, I start with 3x squared equals 9. So what that means is I can divide both sides by 3 first. Don't get too overzealous and automatically think that you're going to take the square root of both sides. I need to divide by 3 first. My goal is still to get x by itself. That gives me x squared equals 3. I can still take the square root of both sides, And when I do, that cancels this square out, and I get x equals, and then remember there's two solutions because root 3 is greater than 0, so it's going to be plus or minus the square root of 3. Leave it that way because 3 is not a perfect root. So if I push the square root button on my calculator and it comes up with a huge decimal, just leave it as the square root. And then it's just a plus or minus. All right, tomorrow we're going to go through more examples of this type and more factoring questions.